So I have to do the obligatory Qualcomm slide here now that I'm part of the behemoth. So $105 billion company. It's fun to work there, really is. After a 50-person company, it's really much more entrepreneurial than I expected, and it's really quite an adventure. They make this thing called the Snapdragon. It's in a lot of phones. And one of the things they want to do with all the extra processing power they're creating is add some kind of novelty right at the core. They're thinking about always-on use cases like the context awareness that the Intel presenter was talking about today. They want the phone to be listening and seeing all the time. And so they brought in the concept of gestures and higher perception, and that's where we fit. So gestures for UI control. We're all familiar with touch gestures, pinching and swiping, or some of us are familiar with motion gestures, so the idea of moving the phone. So you might turn it over to mute or pause it or to not take a call. Rotating for landscape and portrait, everyone's done it. What we're focused on today is touchless gestures. So you're no longer actually engaging with the screen. You're going to control that phone from ½ inch up to 5 feet away, and you'll see some demos of even further stuff. So I'll start with an example, always good. Peter thought that videos would be good at this time of day, so that's where we're going to go. Oh, I don't think we actually connected the video, though. Audio, yeah. I got it here, I think. All right.
여보세요?
So that was launched in fall 2011 and was kind of one of the first use cases people had for not touching their phone. So kind of made a big splash in Korea, but we hadn't really seen it get adopted beyond that. One of the reasons that Qualcomm looked at purchasing gesture tech was technologies like these. They were getting requests from people like Amazon for different modes of interaction. So it takes a while before this kind of technology starts being adopted by the bigger players. But if you've been watching the Samsung S4 release videos,
these ribs are insane. Hello?
Yo, Scott, what's up, man?
You gotta be kidding me. That's how you answer it? Call your phone with my phone. Oh, you gotta be kidding me.
Ooh, Tiffany texted.
Oh, I got it.
That was awesome.
Introducing the Samsung Galaxy S4. The next big thing is here.
So we're starting to see it emerge into mainstream devices. And what's happening now at Qualcomm, because we're on the Samsung S4, is that everybody else who's making an Android phone needs to have gestures tomorrow. And so companies like the iPhone or Apple with their iPhones and Samsung drive adoption by kind of the horde. And so we're seeing a lot of interest in gestures in general, and so you're going to see a lot of it coming. Samsung went a little even beyond that on their smart series of TVs. So I'm just going to show this because it's another Android device that people aren't really targeting with apps yet, but this is a market that's coming as well. great stuff going on. I think Samsung's really, trying to drive the market. It's quite a good thing. There's a few technologies that are being used there, so I'll just kind of go over some of them. For the kind of swipe actions that you're seeing in that kind of 6-inch range above the phone, tends to be the 2D image sensor at the front of the camera, so just the normal webcam-like front-facing camera. For the hover touch that you saw in the Samsung S4 video, where she's really within an inch of the screen, that's just the ProCap touchscreen kind of being amped up to detect something that's a non-touch event. There's other technologies coming into that space right now, like near-field imaging and ultrasound, which basically creates a little sonar field above your phone using a set of microphones. Now that people are interested in it, we're finding all kinds of technologies emerging. So infrared sensors, just all kinds of ways of augmenting your phone to be able to detect hand presence near, beside, and around the phone or the tablet. Coming soon is 3D image sensors. So the TV demo you saw wasn't using a Kinect-like device. It was actually using a normal 2D sensor in that space. So again, a webcam embedded into the TV. Most of the TV manufacturers we're talking about are embedding 2D cameras into their TVs this year, but they're also offering accessories which are Kinects, basically, working with PrimeSense, Soft Kinetic, companies like that, to release 3D cameras coming into the living room space, initially for games, secondly for actually driving the UI. So what kind of applications are we actually controlling? So the ones demonstrated there were primarily event-driven. So the idea of answering your phone, the phone rings, you can then turn on the camera, you can wait for the event, the swipe event, and you can have the phone respond. In that implementation, they did a answer and turn on speakerphone. You saw he just immediately started talking to it. He could have also done the opposite direction swipe to send it to voicemail. In the first example, you saw it was just a single swipe, but Samsung is pushing kind of this 2-swipe approach, I think mostly to avoid any kind of mishits of people doing a single swipe. In the call, you can actually mute and unmute the call by kind of putting your hand over it in a way, or you can hang up the call again with a left swipe. So it's kind of a fully functioned call answer kind of application. And it's using that camera on the front of the phone in that 6-inch kind of space. The notification view, which is the second Samsung demo there, was the idea of finding the finger somewhere above the phone. Now that's an actual very powerful kind of tool. A lot of the problems we have with UIs in general on the phone is that you don't get that advantage of a rollover that you get inside of a normal mouse-driven interface. So here you've got this ability to bring up extra information as you're holding your finger around, and in their case, it was the notification itself that was able to bring up without even kind of logging onto the phone at all. Always-on applications, these are things which are going to be tougher on power. That's going to take a longer time before we're truly able to run those 24 hours a day. But we are implementing kind of these hybrid modes where initially you have this low power mode. So in the TV example, it's not as important, but let's say you're doing an e-reader app on a tablet and you just want to turn the page once a minute or whatever your frequency is. So in that environment, you could raise your hand and then swipe to change the page, but you can't really have the camera on all the time. So the way we do that is the raising of the hand itself is something which we can look for more at half-second intervals, and so we can run the camera very infrequently and then use the fact that it has changed or the scene has changed in order to then turn on full detect, and then you can pick up the swipes. So in that environment, we had hand wave engagement was what Samsung used. We actually just like a kind of a still hand because it's a very rare kind of user engagement piece. We like having an engagement for kind of distance actions because you don't want to be triggering on every little motion the person makes. So by having a very specific engagement gesture, either hand wave or a single pose, you kind of have that uniqueness factor that works for you. Okay? You also saw a hand close for click. That's a very common one. And emulating the mouse is not our favorite use of gestures, but we see that people are going to want to do that. We like interfaces that are kind of more designed along the idea of swiping and maybe turning a circle to get a volume control, those kinds of things. So kind of more optimized for gesture. There's a lot of different use cases that we've been seeing people implement. A lot of the OEMs in Asia in particular are kind of jumping ahead on this. So pausing and playing a movie, skipping a song, all these things where you can just not have to fully engage with the device and kind of control it. Even controlling a PowerPoint would have been an appropriate use in this case. I'm also including some car stuff. We're doing a fair bit of work with cars. So in there, it's kind of having your email read, and you could even zoom into a GPS, those kinds of things. But on the embedded side is where I really think it has value. I just got one of those Tesla vehicles, and it has this big 17-inch screen, and Gmail is up there, and the text spacing is so tiny on Gmail that certainly not while I'm driving, but at certain times when I want to reach down and see something, it would be nice if my finger could get detected and it would just kind of expand the area around my finger. So the same thing for that hover. You could have a fairly dense interface that gets kind of larger for the user to access specific controls within an area by having their finger go in close. So now, what about gesture alphabet? So question, you could do a lot of things with your hand. They're very flexible devices. And you could either take two approaches to it. You could say, what technologies do I have and what are they able to track? Or you could take the kind of what do users naturally do intuitive approach. And so one problem with going technology-driven is you might end up with very awkward gestures. Problem with going the other route is you might end up with gestures that easily conflict or that might be extremely difficult to track. So we did a little study. We have a group that does UX studies for us over in Cambridge, and they did a study where they brought in a bunch of users and they took them through some typical use cases on tablets and smartphones and saying, you cannot touch the screen, but we want you to do this task or this task. So one of those tasks, and I'm going to have us do it here, is to select the biggest shape out of a set of shapes. So when I turn this page here, there's going to be 4 shapes. One of them is larger than the others, and I want you to think about what would I use to select that object. That's all you're doing. Okay, so it's one move. I'll go 3, 2, 1, and I want you all to do a single gesture, and there's no wrong answer. Ready? 3, 2, 1. Okay, so there are some interesting choices there. So one of the primary ones that I saw was actually this. Okay, so that's kind of a grab of the object. Okay, I saw several people do this, which is, the idea of the second object being selected. So that's kind of an unusual choice. There was also several people who did the poke gesture. And so when you get a group of people in a study doing this, what we found was that the poke is actually the most common. And so you can get the idea of just the single finger coming forward. But if you look at those results carefully, top one is for phone, bottom one is for tablet, it's only 53% of people that actually did the poke gesture. So a bunch of others did a poke, but it was more the grab that we saw here. So, and then 15% were kind of this mixed bag. And I don't think anyone ever did that two-fingered thing. So, I think that's awesome. And so the tablet side, a little higher on the poke. And then they also introduced this idea of a tap gesture like this. The device was larger. They felt they could use kind of a larger hand motion rather than the other one trying to be more precise. And so when you get those kind of results, you get some challenges there. So to get 85%, you start creating tracking systems that can handle this, and sort of eliminate the potential of using those kinds of gestures for other activities. So do you glom them into one, or would you rather pick one and go with it and force people to learn it? There's also problems with poke actually, because one thing that people do when they're actually thinking of their finger as a laser and that it's pointing at some specific spot on the screen, and when they poke, they tend not to think about the laser accuracy of their finger angle. And so you almost have to compensate for the lack of motion as they do it by remembering before they started moving what they were actually pointing at. So there's some complexities involved in actually trying to track that well. Fortunately, we found that when we instructed the user to do a specific gesture. If the gesture felt like it was intuitive or natural or acceptable, then they were very readily able to kind of use it again in a later session and remember it easily. And so the main finding turned out to be, by keeping a very small gesture alphabet, you could actually train people to use them for a number of different functions. And if you think about what Apple does with their TV ads, everyone learned how to do a pinch and zoom by watching that Apple ad, and you had no fear of taking that phone and actually trying it because you had seen it done so many times. And that approach is what Samsung's trying to do now with, I'm going to answer my phone with a swipe. So I think it's possible to train people into a very narrow alphabet that's very functional. One of the key things we also found, we did a separate UI study for people engaging with these systems, and the feedback inside the UI is critical. So just like voice input, you're going to have this adoption problem tied to, is it working? And so what we often do now is we have, if you're doing an engagement-based, then you bring up your hand and there's an icon immediately appears on the screen saying, I see it, right? So you bring that up immediately, and then we fill it in over the course of about 300 milliseconds, so a third of a second. So it's not considered a delay. It's just, it just comes up very quickly. And once the hand is filled in, then let's say you're in an e-reader app, you might only have, next and previous, that kind of command. So you'll just have additional icons show you what you can do. So really guiding the user through their experience by giving them that kind of overlay is a great way to sort of empower them in this environment. Okay? And at the moment, we're actually providing this gesture overlay service on Android that ties into the technology underneath. And the service itself can be controlled by an app, or it can be configured for all apps, that kind of thing. This idea of this gesture layer actually brings up an interesting concept. The reason that it feels very comfortable to have these kind of semi-transparent windows show up on top of the device is that you're not truly touching the device anymore. And so by pulling your hand back from the device, there's this concept that I'm actually interacting in the space between myself and the device. Okay? And so you can actually create a whole nother layer of interaction for either the application you're dealing with, or let's say I've got music running in the background and I'm on Facebook and I don't like the song I'm hearing. I can, without having to change my context, I can pop a hand out, get an UI for the background task, flip the song, and as soon as the flip is done, it's back to my app. And so by using this idea that you have this kind of extra layer of control, it's really physically a whole extra UI that you have to access your app. And you can do it within an app itself, but I like this idea of having the background apps that you can control and bring up and create kind of a floating other space. This is more of a practical kind of technical implementation slide. So we have direct access to the sensor, the image sensor in this case. We're also connecting to ultrasound sensors. So there's kind of a gesture system exposing a gesture device in Android. And inside that environment, we have a gesture interface on the Android side which can talk directly to it. So you can directly connect, and then you can actually get the percentage of the hand completion, its exact position and size, whether it's a right hand or left hand. All those kind of details can come to you directly through the gesture API. Or we can run what we call touch injection. And in touch injection, we're really creating an emulation like you're touching the screen and dragging. So we'll just, if you swipe, we'll inject touch events to emulate the person having done that. So you don't have to immediately adopt kind of the custom API to connect to it. You can just run existing apps that way. And we're letting users actually determine which apps they want enabled with gestures and which gestures they want to kind of invoke which functionality. Current set that are out there, on the near side, we have this idea of the near swipe. We have the hover that you saw. We have cover, which is more of a mute kind of functionality. Tap, which is really any select kind of gesture. And then once you get to the far pose, We start with the hand pose detection itself, which has size. We have OEMs in China that are using that actually for a zoom feature on their GPS, just the actual hand position and distance, because the hand gets bigger. It's not truly a 3D sensor, but the hand gets bigger when it gets closer, so you can leverage that data. We have far swipes, which is just, for a quick one at a time, stepping through something. The click and the pointing, or pointer mode and click and drag. And then the circle gesture. Circle is very interesting for scrolling through bigger lists, setting volume, those kinds of things, and it's a very natural gesture. So where is it going? So a lot of you have probably heard of the leap. I'm just going to play a short video for those of you who have not.
You're seeing my fingertip, and this is sort of the direction of my finger. And here's sort of the path that's tracing out. And of course, everything's in full 3D. So you can see, we're tracking that too. And we're not just tracking the fingertips, we're also tracking the entire hand. So here's my entire hand. You can see very small motions of my fingertips are very easy to pick up. And of course, we can do more than one hand. We can do other objects. There's like my arm, or here's a chopstick right here. Subtle motions are immediately occurring on the screen, and so that there's no distance between sort of thought and response.
No distance between thought and response. I love that. And so with that kind of highly responsive technology and sort of the greater fidelity that you can receive with something like a leap, I think the potential for greater control and the concepts that can be integrated with it we're really looking forward to. I think some of the issues with the leap at the moment are that a lot of the demos are really drawing in space. But I think that the potential is there to really integrate it into OSs, and they are releasing on HP platforms in the coming months. So we are going to start seeing them embedded, and I think it's a great step. One thing that we will be doing at Qualcomm is integrating a Leap-like device into our tablets. And so we have a reference tablet design that we promote, and it utilizes 2 sensors plus an infrared emitter. So you can just put those where you currently have the camera at the top of the device. They're going to look at it in IR, and you'll be able to track hand skeletons and get the kind of detail that the Leap can get out of that. So we're seeing a lot of interest already in our ODMs that are wanting to build tablets, and actually they want to build phone platforms, bigger phone platforms that have that kind of tracking in them. So it's going to get very interesting, the kind of fidelity of hand detection and tracking that's going to come out in the next 12 months. And we will be sampling pieces with that by this coming summer. So one of the things that this opens up is this idea that, okay, right now we're kind of at the point where we can detect certain forms of gesture, that there are APIs starting to emerge. There needs to be sort of a coalescing of those across different platforms, which is why we're, at the moment, really touch injection seems to be the more common way for someone to develop this. They don't want to get too caught up in a single platform, even if it is the S4. And so you've got to get to the point where people are speaking in the same language, using the same kind of format. So, we will get to the point where there is a unified gesture API. We are dealing with Google. We're dealing with, various consortiums out there that want to implement a common interface. And eventually, really, we see the entire hand itself can be identified as a skeletal structure in the way that you were seeing inside the Leap there. And so what starts happening with that and these 3D kind of Kinect-like sensors is kind of a whole other level of connection to your device. And when you get it with that kind of instant feedback, the results are quite stunning how personal it feels. And you can also imagine glass evolution incorporating some kind of hand tracking that would allow you to control things a little more subtly than just the single list that they have right now. And so one company called OMEC has been working in this space, and they have a product called Grasp, which is a really a 3D hand skeletonizer taking source data from a number of different sensors. And that skeletonizer can be used to drive a bunch of different applications. One of the simple ones is hand pose recognition. And one of the natural next steps is to be able to do sign language, those kinds of things. So all the kind of very difficult problems start to go away once you're able to actually track a hand that's moving continuously with a skeleton identifying it. So we're quite excited about that direction for this technology. And I'd like to just show something that they've created, which is it's a music application where it's a very novel kind of 3D interface. You actually have your hands all in 3 dimensions in front of your device. Most, we think a lot of flat kind of interfaces now because the touch screen is a single surface. But as you pull away and you start getting more 3-dimensional, then I think the possibilities become really interesting. And what they've done here is the music that you're hearing is actually being generated by the person as he's kind of plucking this virtual harp. So we'll play that. And with that, I hope I've given you a glimpse into my world.